Let's continue to study why we say that D is the transformation matrix in the B basis. Let's recap. This is X in the standard basis, and it is related to X in the B basis through the change of coordinate matrix. PB contains the set of independent vectors spanning the B coordinate. In my work examples, I'm lazy. I do not write PB. I simply write B for the basis B, where B is equals to PB, containing the set of vectors representing the B basis. Once we have understood this equation, then simply to get X of B, we move PB to the left hand side by pre-multiplying by P minus 1, because PB is square and invertible. So X of B is related to the standard basis by pre-multiplying by PB minus 1. Now with this recap, we now want to study why we call D the transformation matrix in the B basis. Y is in the standard basis is the transformation A multiply X in the standard basis. Remember that typically we do not write the standard basis because it is understood. Therefore, or in the case where A can be decomposed into PDP minus 1, then what we want to see now is A equals to PD by minus 1, allowing us to substitute into this equation. We observe that we can group brackets in this way, P minus 1x, and if we study our recap, the change of coordinate, something multiplied by P minus 1 with the input being in the standard basis is exactly what we are having here. X is in the standard basis, P minus 1 is the change of coordinate inverse, and what happened is that this will give us the X in the B basis. We then continue and we write this as a B basis. We then pre-multiply with by D. What this shows us is that we are transforming X in the B basis using the matrix D. So we get Y of B. Y of B is equal to simply D times X of B. Now, let's again recap. If this is Y of B, this is Y, then by multiplying on the left by PB changes the Y in the B basis to Y in the standard basis. What we then see is that this is what's happening in the last equation here, therefore resulting in Y in the standard basis. Now, through this interpretation, we now can see that D is the transformation A in the B basis. And this P minus 1 converts the standard basis X into the B basis. This P converts from the B basis back into the standard basis.